So now we're going to go ahead and take a look at example 1 on your example page. So take a minute or so to read through this and underline any important information. You can go ahead and pause the video if you need to. So now that you've kind of read through this, let's underline some pertinent information. First of all, we're looking at overhead reach distances of adult females. They do give us the mean, and that would be the population mean, is 205.5 centimeters. The population standard deviation is 8.6 centimeters. Now, this is also important as they tell us that these overhead reach distances are already normally distributed. So what that says is our sample size can be any size we want it to be if we're looking at a sampling distribution. And that sampling distribution will form a normal distribution because the original population of reach distances were already normal. So, number 1A says, if one adult female is randomly selected, find the probability that her overhead reach is less than 222.7 centimeters. Now, again, we're only looking at one female out of the population. So this is not a sampling distribution. Well, it can be. It could be a sampling distribution of size 1, sample size 1. But in this case, we are just going to try to determine the probability that a single individual female from the population of females would have an overhead reach of less than 222.7 centimeters. So what we want to do, and this is going to become just regular hat for us here, we need to look at these three things: shape, center, and spread. And so first of all is the shape. Since we're using the population shape, the population distribution, because we're only looking at one female from that population has to be normal. And it is. It said right up here that the population was normally distributed. So the population shape is normal. Why? Because it said it was. Now we're looking at the center. And since we're only looking at a single individual, the center of this distribution of individual females would be the population mean, which is 205.5 centimeters. And then the spread. Well, again, since we're only looking at one female from the population, we're going to use the spread will be given to us as the population standard deviation, which was given as 8.6 centimeters. Now that we know all this, we can go ahead and figure out, okay, what's the probability that a single individual, a single adult female, will have a reach of less than 222.7 centimeters? Well, we can just go to now our stat app. You can go to the ArtofStat app, the normal distribution, or you can go to the StatMedic applet if you've been using that, and we're going to do that. We need to figure out what this is. So I'm going to walk over to my computer here, reduce this, and then we're going to go to our normal distribution here. And again, we're going to find a probability. So the mean, population mean was 205.5 centimeters. The population standard deviation is 8.6. And we want to know the probability that the reach distance was less than, so we've already got this, and we're going to go 222.7. Oops. So if you go up here and you take a look at this, now again, we're looking at a probability, not a percentage. That's the percentage, 97.72%. So really all we need to do then is, let me go back here to right here. And that is 0.9772. So pretty high probability that a single female would have a reach, overhead reach of less than 222.7 centimeters. Okay. So I'm going to stop this here. This is just A of number 1, and on the next slide we're going to look at B and hopefully C.